Hello friends, my name is Vikas Sharma and today I am going to explain you how you can solve the problem using the backtracking. In this part 1 of the video, I am going to explain the following topics. The first, in which kind of problems you can use the backtracking approach. Second, what all are the key points that you always need to remember while solving the problem using the backtracking. Third, I'm going to take an example with the code and tries to map all my key points to the example so that you can understand what all are the key points you always should remember to solve the problem using the backtracking. In the second part of this video, I'm going to map the backtracking approach to the dynamic programming approach so that you can understand with the simple tweaks you can easily map your backtracking approach to the dynamic programming approach where it is possible. So to understand the second video, the dynamic programming video, you need to watch this video till the end so that you can understand how you can use the backtracking. So what is backtracking? Backtracking actually is an approach to solve the problem. It is not a problem, it is an approach to solve the problem. It is actually a recursion method where we try to explore all the possible paths or all the possible solution and then gives the output. So now let me explain you what all kind of problems you can solve using the backtracking. So let me first take an example. Here is a 5 into 5 grid matrix is given to you, and let's say I'm standing at the position 1, let's say 0th row and 0th column, that is cell 1, and I want to reach at the end of the matrix, but according to the problem statement I can take at a time one step towards the left or to the down. But there are some obstacles are there in the matrix where I cannot jump to. So, for example, in this matrix, I cannot jump to the left because there is an obstacle there. I can only go to the down. So, now my problem statement could say that I want to reach from start to end. Is there any possible path available? So yes, there is a path available to reach to the end. Now, the second problem says that I want to try to find all the possible paths that start from position 1 and take me to the end. Yes, there are multiple paths available, right? Now the third problem could say that I want to find the best path that take the minimum number of steps to reach to the end. That problem also can solve using the backtracking. There are multiple kind of problems. The optimization problem, like the third one where I want to find the best path, can solve using the greedy or the dynamic programming approach that we will talk about in the next part of the video. But in this part, we can also solve these kind of problems using the backtracking. So now let's start talk about what all the key points that you should always need to remember while solving the problem using the backtracking. First, find the starting point. So first, you need to find from where you want to start your program. In this example, I'm standing at the position 1, where I'm standing at the 0th row and the 0th column, right? So I want to start my program from this position only. So finding the initial position is quite easy. You can easily find it. Second, you need to find all the possible paths that you can take from the current position. So in the previous example, I can go either towards the left or towards the down if possible. So there are two possible paths are available from my current position, right? Let's say if I take a step towards the down, now there are only two possible paths are available. Again, I can either go towards the left or towards the down if possible, right? Let's say if problem says that you can go towards like down, up, left or right. So there are 4 possible paths available from any given position if you can take those paths. So this is really very important point. You should always need to figure out what are all the possible paths that you can take from the context. Point number 3, find the base condition and the constraint where you want to stop your backtracking path to go further. For example, in my previous example, let's say I'm standing at the position 1. I cannot go towards the left because there is an obstacle there. I want to stop my path to go further, right? In that case, I can only take step towards the down, right? Or let's say I'm standing at the position 4th row and 0th column. From here, I cannot go towards down because in that case, I'll go out of the matrix. That is not possible. So I can take only step towards the left, right? So you always need to find where you want to stop your backtracking path. Otherwise, you will loop through into the infinite loop. So that's really very important point to remember. Now, let's talk about the point number 4. Find the values that are required to pass into the next call step. As you know that backtracking is a recursive approach where we recursively call the function again and again, right? So in this example, let's say I'm standing at the position 1 and first I take the step towards the down. So what I'm going to do, I'll first increment the row by 1 and keep the column as it is so that I can jump to the next position and take the steps further, right? So this is also an important step that you always need to remember with all the values you want to pass to the next call step, right? Point number 5, always virtually make a tree of your recursion call step so that you can understand your recursion in a much better way. I would especially recommend for the beginners first make a tree, then write the code, because you first need to understand how your recursion call set works before writing the code. In my next example, I'm going to first build a tree with all the key points that I just told you, and then I'll map my tree to the code, and then you're going to understand writing a code after making a tree is really very simple task. It's not that tough. Alright? So now let's jump to the next problem statement. So let's start with the next problem statement. I have seen that this problem statement has been asked in many interviews nowadays. So it would be interesting for you to know that how you can solve this problem using the backtracking. So let's start with the problem. So in the problem statement, we have given an old kind of numeric keypad where a number represents some kind of letters or the combination of letters. For example, here 2 represents A, B and C. 3 represents D, E and F, and so on. And we have also given a string of digits where digits can go up to 2 to 9. Alright? And the string length can go up to, let's say, 10 maybe. Alright? So now in this problem statement, we need to return all the possible combinations that the string of digit can represent. For example, let's say we have given the string of digit is 2, 3. Alright? So now, what all the possible combinations that they can make? They can make like AD, AE, AF, BD, BE, BF, CD, CE and CF. And let's say if the string of digit is 2, 3, 4, what all the possible combinations what they can make? They can make ADG, ADH, ADI and so on. So now we need to solve this problem statement. Alright? So let's start with this problem statement. Here we have given a digit that is 2 and 4 and the keypad in the form of map where 2 represent A, B, C, 3 represent D, E, F and so on. Alright? So let's start remember the key points that I have told you at the starting of this video. That first point was that we first need to figure out what should be our starting point. Alright? Or the starting value where we want to start our recursion. Alright? Here we can start at index 0 that represents 2. Alright? So finding the starting point of your recursion set is not tough. Right? You can easily figure out that. Now, I have also told you in the key points that we should always make a tree virtually to solve the problem first. So to understand the recursion concept better. Alright? So first I'm going to make a tree and then map my tree into the code. Alright? So let's try to build a tree. Alright? So in the tree, I initially start with the 0th index that represent, let's say index represent from I. Alright? Another point was that we also need to know that what all the values that are required in the next recursion call set, right? So here, along with I, we also need to maintain one more variable, that is string, that maintains the current combination of letter. Alright, so let's start with the empty string here. Let's take it str. Alright. Now the next point was we need to figure out what all the possible paths we can take from the current position. Alright. Here 2 represents A, B and C. So there can be possibly 3 paths we can take from index 0. Alright. So we can take 3 paths. Alright. One for A, one for B and one for C. And in every path, in every recursion call step, we always increment I and also appending the letter that represents that path. So this path, so A is representing this path, alright, B representing this path and C representing this path. Alright. Now increment I with 1, that will become 1, and we also append the representing character with the str, and now this string can this string has become A. We append empty string with the character A. Alright. This part represent now B. Now this represents C. Alright. Now we are at this position. So now we need to think like from this position how many paths we can take. So we are now at index 1. So here 1 represents 7 and 7 represents 4 paths, like 4 characters P, Q, R and S. So from this position we can take 4 paths. Alright, 1 for P, 1 for Q, 1 for R and 1 for S. P, Q, R and S. But backtracking is actually a depth first search approach where we first solve the depth, and once the depth is complete, then we solve the other parts. For example, here we first solve this part that represents A, and once this A1 and A3 completes, then we explore the path where we have index 1 and the B, and once this path is fully explored, then we explore for 1 and C. Alright. So here we first explore the path for P, then we explore path for Q. Alright. So let's first explore path for P. Alright. P. Now here we increment I with 1, that is 2, and we append the representing character with a string, that is now become A and B. Right? So now once it complete, then we check is there other depth available. So can we go where index becomes 3? Is it possible from here? No. And that's where our next point comes in, that where we need to define the base condition and the constraints where our recursion cannot go further, where our path cannot go further. Alright? So our condition here can be when our I reach to the length of the digits, we need to stop right there. Right? Because if we increment the I with 1 and make it 3, we cannot find 3 in our digits, like third index in our digits, right? So we need to stop here. So that's our base condition and the constraint. So whenever length becomes 2, We need to stop here. And the one more thing that we need to do here is, as we have get our first combination of letter, so we need to print AP or store AP somewhere as an output. Alright. So we print AP and then just return from this call set back to 1 and A. Alright. And then start exploring the next path. So now the next path would be 2 and Q. So because the next path is Q, right? So this path represents Q. Now again we cannot go further because we have reached to the length, right? We will stop here, store the output somewhere or print the output and just return it from here. We cannot go further. We again store it and return it. We again return it. Alright. And then we explore the next path. Then we explore same for R and for S also. Let's say 2AR and 2AS. Alright. We print it and then we again return back to this. Now, is there any path remaining to cover up? Yeah. We have already covered all the paths, all the 4 paths, right? So now we also return from here. Alright. Now let's see, okay, is there any path available to cover? Yes, there is a path available. We haven't covered 1 and B, right? So now we are going to cover for 1 and B. Alright. So now also from 1 and B, as we are at index 1 that represents 7, that can be possible 4 path. So now the first part represents P and that will make our combination string as B and P, right? And as we reach to the length, we again just print it and return it from this call set. And same way we explore all the path. And from same way we also explore this path as well. And that's how we can simply print all the possible combinations that can be possible from this digit. Alright? So as you have seen that we have just figured out what is the starting position and what are all the possible combination available, or what all the possible paths are available from the current index, what values are required to go for the next cost set, and when we want to stop in our recursion path. So I have just covered my 5 key points that I have explained to you, and we have completed the backtracking. Now we will try to make or map this backtracking problem or this backtracking tree to the code and understand how easy it is to create how easy it is to write the code now after creating the tree. So now let's start writing a code for this problem statement. We have given a string that called digits and also a map that called numpack. In the map, key represents a digit and the value represents a combination of letters. Now let's start writing a method. Let's call the method combination. Alright. Now we need to think that what all the parameters are required for this method. So here we are maintaining I as an index and str as a combination of letters. Alright. And the same parameters we are required for this backtracking method that we call a combination. Alright. Now we need to think that what all the possible paths I can make from this position or from this state where index is 0 and string is empty. Alright. For that I can just simply get the list of letters from the map corresponding to the current index. Alright. And just loop through for all the letters in the recursion call. Right? And now we need to think that what values we need to pass in the recursion call set to take the next decisions, right? Here we need to increment index by 1, and also we need to append our current representing character with str. Alright, the same we are doing here. Right? Now we need to think that where we want to stop our recursion call stack, or recursive path. Right? We need to stop when our index becomes the length of the digit. Let's say where our index becomes I is equal to digit dot length. Right? But before just returning from this call set, we also need to print the combination of letter, so that as an output we can print all the combination of the letter for all the paths. Right? So here we just print the combination of letters. So in this part of the video, I have explained the 5 important key points that you always need to remember while solving the problem using the backtracking. In the next part of the video, I'm going to explain how you can easily convert your backtracking approach to the dynamic programming top-down or memorization approach very easily. Alright, so those who don't know how to approach to solve the problem using the dynamic programming, please watch my next video. So guys, this is the end of the video. To share your support and love, please give us a thumbs up to this video, share this video, and subscribe to my channel. If you really think I want to improve something in my videos, please give it a comment below. I will improve in my next video. Thank you.